Okay, so now we should be ready for the next enhancement, part 4, where we will delete a node out of the list. So let's go ahead and document when this will happen today. So that would be 02/23/2020, and that would be part 4. Again, this is an enhancement. And of the class and the application to delete a node, or what we call a record, if you're looking at it from a database point of view. Let me just write this correctly. That would be a node. So the idea behind this is we're going to need a new feature within the application to be able to delete an existing record that has a specific index or a specific key as we designed in part 3. So we're going to use what we've accomplished in part 3 to help us now delete a record. Okay, so we need an extra feature in our menu. Let's start with that. So over here, we're going to we'll just put it right here since the list, or view the list, I'll make it my last item anyway. So any editing will be 1, 2, 3. So that would be here, and that would be delete a record based on a key. Okay, so that would be the requirement for this one. We will shift view the list to be number 4 now, and exit to be number 5. We need to reflect that back in our application. So let me just save here and get down to our application and add that into our switch statement. So we have case 3 over here. So we're going to need case 3. And we'll put a break. I'll come back to it. At this stage, change this to 4 and this one to 5. And make sure your while loop is based on the value 5. Save everything. Now is a good time to go ahead and compile and run, just to make sure that everything looks good. If we do a 4, obviously there's nothing. It's an empty list. If we do a 1, we should be able to enter some data. We do a 4 again. Then we will see that we have 77 with a key of 0. Now, the keys are what's going to be important for us to delete things. So let's say we have this, 99, so this would have 4 again. As you can see, we have a key of 1. So if we wanted to delete that one, we would use key number 1, right, to delete that payload that has 99 in it. Okay, so at this stage, let's go ahead and exit. Okay, now under case 3 is where we will ask the user to enter a record. And notice here I've already included rec key right here that we're going to be needing. So I was coding a little bit ahead, so I put this one here. So let's go ahead and do, so payload for node, and the next one is the key index for the payload. Right, so the payload for the node and the key index for that's rec key right here. So we'll ask for that value in case 3. So something like this, so we'll have a C out here, asking the user, enter the key for the record to be deleted. And that would be a C in here, and that would be our rec key right there. Now, we would like to do something. We would like to call it maybe a function that will do this job for us. We could do a myList arrow delete record if we create that function, or we could make it a little smarter. where we have an if statement here. Let's suppose we wanted to delete a record and it doesn't exist, or the list is empty. We would like to get a message that says no record deleted, else record deleted. So how would we handle this? So something like this, maybe. My if statement here. So we're going to have an if statement. And my list. Now, this function that I'm going to write here, I haven't designed it yet. And that would be called, let's say, delete record. So that would be the function that I want. I will pass to, as an argument, my list to it, just like I did everything else. And this time, rec key. So it will compare the key that you typed in to be able to see if it will delete, if it finds that record or not. That is why this will return a Boolean. If it does, then it will delete it. If that happened, if this is true, then cout record deleted. Then you get a message that says, okay, the record got deleted. Else, cout no record was deleted. So this is a good indicator as to what happened as soon as you picked option 3 and you entered a specific key. Now, there is no function delete record right now. If I compile this, you will get an error. You need to add that feature now in the list.h, and you need to implement that function in the list.cpp. So that's our objective for the day, or in particularly part 4 is to design delete record function. Okay, let's start with the header file. That is definitely an accessor, so a mutator, since you're going to make changes, right, to the actual list itself. We know it's going to return a Boolean, and we're going to call it delete record. Now you could call it whatever you want, delete node. So in our case, it's going to follow pretty much the same logic I've used before in accessing a list and manipulating that list. That is why I'm passing in this manner, plus an integer, which in this case will represent the key, not a payload. Okay, so let me save this again. So that's my prototype for this particular mutator. Now we're going to go ahead and code or do the hard work for this mutator right here. So we're going to write it under mutators. So let's do it right here where my prompt is. So list, and it returns a Boolean, so do not forget that. So list, and that would be delete record right here, and we're going to pass list and %head. So you want the head of the list plus let's call it rec key. Even though I named it that way in the main application, it doesn't matter. You're just passing by value. You could rename. Okay. All right. So this is where we have to think about how the deletion of a node is done. Typically in data structure, to do this is not unheard of, and this is the way it's done usually, is you need at least 2 pointers. One will follow the other, so there will be offset by 1 node. At the beginning, they will both point to head. So we will have position, for example, just like the other, like this one, list, position. We're familiar with this one, equal head, move around. We will have a loop that allows us to move things around. So let's just look at what a loop like this would look like. While position is not equal to null, and then the way you move is you make sure that within the while loop, somewhere, I might have to modify this code here. I'm just showing you again what goes on in here. So you need to do position equal position arrow next. So this has been typical for everything we've done so far. You agree? So otherwise you won't be able to move through the list. But we're going to do this loop after we've asked a few questions. After we made sure that, first of all, where are we on the list? Because we're going to see a particular case where if you are pointing at the head, and that is the item you want to delete, you're going to have to do a special deletion, which means you're going to have to move the actual head to the next item. Okay, so let me delete now what I just wrote here, because we're going to see it again. It's going to come back. And let me just put my other pointer, and let's call it previous position. And guess what? Make it equal to head as well. So as I told you before, just initialize them both to the same point. And I need a Boolean to return. So I'm going to call it a flag. And that flag will be false if there's no match or you couldn't delete anything or the head was null. Right? So why would the head be null? Because your list is empty. Okay, so either way, so we could do a bool. We're going to call this one flag. We can initialize it to false to begin with and just return flag here at the end. Okay. Remember, I'm writing code from scratch, so we'll experiment with a couple things and see how this moves ahead. At this stage, I can actually compile everything here and rebuild all. Okay, I have an else issue. Let's see what's going on. Record deleted. If, I got a semicolon under at the end of my if statement. Take it out. Okay, so it's a good thing that I compile now before I have too much stuff. There you go. Now we're good. Yeah, so I had a semicolon where it shouldn't have been. Right here, because initially I was thinking about doing my list delete record as a function, simply you call it, just like we did push back and push front. But at this, what I decided at the end is to make it return Boolean and use it to see if we're deleted a record or not. Okay. As a matter of fact, we could test it right away. Well, if you test it now and you say, okay, well, let's go ahead and delete a record. It doesn't matter what you enter, 99, there's no such thing. No record was deleted. You could say that it's working just fine there. Even if you have something and insert 88, and let's say we do 4 to see what it is, if you've ordered a list, and we put, let's go to 3 and put 0 there, nothing will happen because we haven't done the logic with which we're comparing that key to the items on the list. Now remember, on this particular case, we have one node in the item that has 88 in it with a key of 0. Okay, let me hit 5 for now. We're going to come back to this. So everything seems to be smooth up to this stage. So now let's work out the logic and how to resolve. First, let's start with, and we can clean it up, first with an if statement to check if the head is null. If it is, then simply return flag, right? So that means your list was empty anyway. So if, for example, head equals null, well, that means you really, so you can make flag equal false. Do it this way, right? Great. So, or we could have put a return statement there. Okay. We've already initialized the flag to false anyway, so that's okay. So we want it to be true somehow when we do encounter a record that has a matching key. Well, that's going to happen here after you evaluate the list. So that means it exists. You don't have a null. So that will be the else of this if statement. So let me just put a curly brace, close a curly brace. That's going to be the essential meat of going through that while loop. Remember? While position was not equal to null. Right? So if that's your while loop, let me just put a curly brace and close the curly brace. We're going to do a couple things here. Unlike last time where we did only one thing, let's do that again. So see if you're familiar with this. And one of them was position equal position next. Otherwise, you're not going to move anywhere. All right, so we're all familiar with that. Except this time, I'm going to do one more thing. I'm going to make the previous position lag behind it. And you're going to do this right before you do this command. So previous position will be equal to position. So this way, at any given time, previous position after you move from the head, previous position will always lag position. This is going to be critical in terms of relinking. When you remove a node, right? You want to relink to the list. That means, okay, well, how do we do that? Well, one other thing I'm going to introduce here is when we remove a node, we're going to also free it up from memory. And I'm going to use the keyword free somewhere. Okay, all right, so we're going to get to that in a minute. So first, I have a couple situations. I have one where you're going to handle the situation where there is only one node, or you want to remove the first node. Right? That's going to be critical. And then we can have another case where, okay, well, we're going to be deleting anything but the head node. Okay? So deleting the head node is going to be the first thing you need to worry about. Okay? But in either case, your if statement is about comparing your position by dereferencing the key. Is it equal to the actual rec key that you passed? And let's put curly brace here and close the curly brace here. This is the meat of the logic. It's going to be right here. So first we will start, what if the node you're trying to delete is the head? What if head is to be deleted? Right? Well, we're not going to delete the head in particular. What we're going to do is move it to the next position. Right? So we're going to move it to the next position. So first, obviously, you need to evaluate that case. So if position equals head, that means at this stage, you are still pointing to head. If that's true, let me just put a little space here just so you can see the logic nice and clean. And let me just write up right next to it here, right here. And I'm going to say, well, if that's the case, move the head, the actual head, move it to what the position is pointing next. Perfect. Else, well, else what? Else you're not dealing with the head. You're dealing with anybody or any other node other than the head node. So else, and well, in that case, it will be a classical previous position next equal position next. That's how you're going to delink, right? Or actually relink the previous item to the item up front while skipping the one in the middle. All right, so the best way to do this is a drawing, but you will pay attention when you see the code here. So previous position. Next. So this is the key here. Equals position next. Done. Well, not really, but that's okay. You've already at this stage done a couple things that allowed you to either evaluate if you're at the head or not at the head, and move your pointers accordingly. You need to do more things. Now you need to get rid of position. You need to free it. And you need to switch the flag to true, and you need to break while you can because you have a match. Break now, otherwise you're going to be going. And so right before you break, go ahead and free position. And turn the flag to true, because that's what you will return. When? Right after you break. Okay, well, let's see how this will behave. So let me save all this. And let me just go ahead and link everything. And let me see, what do I have? Had position, missing an I there. Okay, very good. So let's go ahead and do it again. Below. Perfect. Let's see if it works. Now, in my application, there isn't much to do. The code will remain the same, right? You're going to be calling the delete record. You're going to pass the key to it. Okay? And what's going to happen is, once the key is passed through, you've got your position and previous position both pointing to head, a flag that is false, right? And and it will remain false if the head is null. That's fine. Remember, this is rough logic. You can fix it up. You could have rewritten this if statement in a different way. But right now I'm just driving the logic as raw as I can, and hopefully things will work. So next, I have a classic while loop here to move through the whole structure or the whole list. Except now at the bottom here, not only do I have position is position next, I need to move the previous position, with a lag of one record behind it. And the meet happens in this if statement, right? One first, if there is a match. If there is no match, you don't break, you go all the way to the end, and you're going to be returning a false anyway. If it's true, that means the key matches somebody. Right? You've moved through the while loop and a key matched someone. Well, that's great. So that means now, is it the head or is it another place? In either situation, you're going to have to free that position, which is the node you want to delete, and switch the flag to true, which means there was a deletion, which means at the end, when you return the flag, you're going to return a true. Make sure you break. This break is going to kick you out of the loop. Okay, so the moment you find the item, get out. Okay? All right, well, let's see how that behaves right here. So we've got this application here. So I'm going to just point out to case number 3, so we'll look at it from there. Compile and run here. And let's go ahead and do, first, if you want to view anything, the list is empty. Let's go ahead and put an item. And let's put 88. And let's do a 4 here. Excellent. So now let's suppose we want to delete that one. Right? So we have a key of 0. Let's go ahead and try to delete that one. So that would be option 3. And enter 0. And notice it says record deleted. That's awesome. Well, let's see if it actually did delete it. So we're going to hit 4. And the list is empty. Fantastic. Well, let's put more stuff in there. So let's put 1 again. Let's put that 88 again. Let's do another one and put a 99 in there. Let's do a 2 and put a -1 in there. Let's do a 4 and see what we have. Right? So starting with a key of 0, we had an 88. Key of 1, we have a 99 as payload. Key of 2 in the back. Right? So we have a -1 with a key of 2. let's suppose now we want to delete 0 again, right? So somewhere in the middle, right? So great. So you're going to enter 3. You're going to enter 0. Well, let's do 4 now. Let's see if 0 is gone. And sure enough. Well, let's say now we want to delete the tail, which is the payload of 99. All right, well, that's key number 1. Right, so there you go. So let's see if it's gone. And it is. Let's suppose now we want to delete the last one, which is a key of 2. All right, well, let's see how it works. And let's do 4. And the list is empty. So it works just great. It works wonderful. So let's go ahead and 5 exit. Now, will it require some improvements? Absolutely. Especially with this if statement and so on. But right now I'm going to leave it the way it is so you can actually visualize the logic behind the deletion. And this the fundamental trick to this is to have these 2 pointers instead of 1 to traverse the list and identify the node that you want to delete and move the pointers accordingly. And then free up the node out of memory that you don't need anymore. And the rest is just the mechanics of how you traverse the list and make sure that your delete record returns a true in case you found a record and an actual deletion happened. Okay, on that, thank you for your attention.